Now we're going to look at our last section, and it's over the derivative, and the derivative will be with the majority of the semester from here on out. Average rate of change is your slope, if you remember from your pre-calc class, and that's the difference of your y's over difference of your x's. Another way I could write that is f of x plus h minus f of x over h, which is called your difference quotient, which you also had in pre-calc. And we've seen that a little bit earlier. Now, the value of the slope indicates whether a linear function is increasing or decreasing. This comes into play a lot in our chapters that we have after this. If my slope is positive, remember that your linear equation rises from left to right, or it's increasing. If your slope is negative, less than 0, the function decreases because it falls from left to right. If your slope is 0, which we saw in the last section, the function is constant. It's horizontal. If slope is undefined, the line is vertical. Now, a tangent line. This goes back to some geometry that you might have had. There's a difference between the tangent line and the secant line. A secant line is sort of like the average rate of change because I have two distinct points. A tangent line, on the other hand, to a curve is at a singular point. It's the line through that point whose slope matches the steepness of the curve at point A. Now, you might go to page 518 and look at figure 7 because it's got a lot of tangent lines, and it's, it makes this a little bit more clear. Now, our derivative. Here's a new notation, f prime of x, and you will need to use this notation. This is on page 519. It's instantaneous rate of change, or slope of a tangent line, or velocity. It's all three of these things. We use it a lot for instantaneous rate of change and slope of a tangent line. So the instantaneous rate of change, slope of your tangent line, is equal to f prime. Now, if you'll notice this, we have already done this. This is your difference quotient, and once we clean up the difference quotient, then we take the limit of it as h approaches 0, provided that the limit exists. Its units of measurement are units of f per unit of x. Remember that this is still slope, and it's your y's over your x's. There will be some problems on the homework where you have to indicate what the units of measure are. So usually it's a good idea when they refer to that, go and see what y's are and what your x's are, and just write it as a fractional word. So here's instantaneous rate of change for a function f when x is equal to a. That's our derivative. Get used to that word, derivative, provided that this limit exists. Now see if this sounds familiar. First thing we have to do is find f of x plus h. Once we get that, we subtract our original. Once we clean that up and factor out an h, we will then divide by h. So that the first three steps are my difference quotient. The last thing calculus-wise is we're going to take the limit of that as h approaches 0. So here's some example, or an example. I've got a quadratic. I substituted in wherever I see my x, parentheses and all, I place in my x plus h, FOIL, distribute, no like terms ever. Next part is to subtract my original. Please be careful here. When you subtract a function, especially if there's more than one term, it is to your advantage to use parentheses because the negative gets distributed through. There is going to be major cleanup here. At the end of your cleanup, this third line, every term should have an h because I need to factor it out. in the next step, I'm going to divide by h. So this is why I factor out an h, so that I can eliminate them here, since they're like factors. And that's my leftover. So now I'm going to take the limit of what I've got remaining here. And if you'll notice, there's no division, so I put 0 in for h. So at 2x minus 2 is my derivative. Here's my new notation. Here's my original, and now my derivative, going through all this 4-step process, is 2x minus 2. It's a new function derived from the original, and this is why I have to use notation. Instantaneous rate of change of f, say at x equals -4, you substitute -4. That would be f prime -4 substituted in. So the slope of the tangent line at x equals -4 is -10. I could then go find the tangent line. I've got my slope. If I put -4 back in the original, I can get my point. So I've got a point, I've got slope. I can go find that equation of the tangent line, which on the homework you're going to have to do. Now, non-existence of the derivative. A function is not differentiable at a point C if any one of the three of the following exist. If you have a sharp turn or corner, if you have a vertical tangent, remember this is undefined, or if your function is broken at that particular place. So there are 3 instances. So on page 523 there's a very nice figure that has all 3 of these, and you will need to know these for the test. And I believe that's it for this particular chapter handout. Thank you.